The effects of Hurricane Juan on Point Pleasant Park's succession from 2004 to 2022. The effects of Hurricane Juan on Point Pleasant Park's succession from 2004 to 2022.
Dalhousie University is located in Mi'kmaq, the ancestral and unceded territory of the Mi'kmaq. We are all treaty people. For this experiment, we will be examining the succession in Point Pleasant Park after the damaging events of Hurricane Juan in 2003. We will be using data collected from 2004 to 2022 to determine whether there has been succession. Succession is when a mix of species in a habitat change until there is a dominant species or climax community. For example, a mature forest, this climax community can be disrupted by a disaster, like a hurricane. We will be studying whether the overall forest community in Point Pleasant Park has changed, how the density of the dominant species in 2004 versus 2022 has changed over time, and how the chosen community metric has changed over time. This is important to society because if the entire species composition of a forest ecosystem changes, it can have a drastic effect on all the other organisms which inhabit said area. We have used post-hurricane vegetation recovery in an urban forest as background information for this experiment. In addition, Point Pleasant Park is located in Mi'kmaq, the ancestral, unceded lands of the Mi'kmaq, and we acknowledge and appreciate that we are all treaty people. We will be quantitatively analyzing species of trees in Point Pleasant Park, and this was Shannon's index, diversity index, richness, density, and diameter at breast height. As a result of the destruction of Hurricane Juan in 2003, Point Pleasant has displayed succession in the following years.
The experiment that was conducted was taken place at Point Pleasant Park in Halifax, Nova Scotia. Students walked into the woods to their given data collection site. The sites were chosen based off the data from when the park was surveyed after Hurricane Juan. The chosen parts of the park had the highest hurricane impact on forest structure. Once groups got to their site, there was a roped-off area split into 4. Each group was handed a booklet with tree identifications and a circular retracting tape measure. Students then went off into their groups to their assigned quadrant. They then went to each tree within their quadrant and measured greater than 2.5 centimeters in diameter at breast height. The graph chosen shows the total density of trees within the quadrant sites of Point Pleasant Park with an R value of 0.5281. The question was, how has the overall forest community changed over time? Why and what will you predict will happen to the overall community as the forest moves towards its climax community? Why? Linear regression analysis was used to find the total density, 400 meters squared, of trees within different quadrants throughout Point Pleasant Park in Halifax, Nova Scotia. The data was collected after Hurricane Juan from 2004 to 2022. The data had increased slowly throughout the years until 2015, when the total density skyrocketed to 283 meters squared, which was the total density's highest point. I'd predict that the forest will reach almost 300 meters squared, then start to decrease once again, then slowly started to decrease until 2022, 253 meters squared. This indicates that the total density had succession.
My question was, how has the density of the dominant species in 2004 as well as the dominant species in 2023 changed over time? Why? What can you predict will happen to the dominant species and the community metrics as the forest moves towards its climax community? Why? The results to this question are in the graphs below. The density of the dominant trees from 2004 to 2022, on the left is red maple and on the right is red spruce. Our results show how linear regression analysis was used to examine the density, 400 meters squared, of the dominant red maple and red spruce in Point Pleasant Park after Hurricane Juan from 2004 to 2022. There is an increase in density for both dominant species from 2004 to 2022. In 2004, there were no red maples present, and in 2022, the density had increased greatly. You can see this in Figure 2. For red spruce, the density in 2004 was low, 13 meters squared, and in 2022, the density was almost quadrupled, 48 meters squared, indicating that succession has occurred after Hurricane Juan in Point Pleasant Park.
We wanted to explore the species richness of trees at Point Pleasant Park in Halifax, Nova Scotia, to determine whether the succession has been displayed. The community metric of richness in Point Pleasant Park has doubled in the years following Hurricane Juan. This can be seen in Figure 4 as species richness is represented on the y-axis and time in years on the x-axis. This is important to examine because changes to ecosystems such as succession will affect all the organisms that inhabit the area.
In 2003, Hurricane Juan hit Halifax, Nova Scotia, taking full effect, destroying a lot of the overall forest and landscape. Point Pleasant Park took a hard hit as a lot of its trees became uprooted. The community has changed throughout the years from 2004 to 2022 in a positive manner. The overall community has grown over time and increased in population. This would be because the hurricane had such a massive impact on the park and that there was barely any trees left by the end. This means throughout the years, every tree that grew had a lot of sunlight for itself and a lot of space for its roots to grow. This would cause a lot of trees to grow at one time and for them to grow at a more rapid pace due to the nutrients given. We predict that when the forest moves towards its climax community, the amount of growth and number of trees will almost stop or immensely decrease. This would be because of a factor such as no room for growth, meaning with all the roots in the ground, more trees will have no space to flourish. Also, once there's a max number of trees, the new trees that do grow wouldn't get as much sunlight or nutrients on their leaves because of the newly developed forest canopy.
Due to Hurricane Juan in 2003, Point Pleasant Park underwent a stand-initiating disturbance, which is an event that causes large-scale loss of the current forest, resulting in cessation of new forest growth. According to Neely et al., 30% of the trees that were present prior to Hurricane Juan were completely wiped out from the measured quadrants, including the dominant species, red maple and red spruce. This disturbance gave the chance for new growth in the forest. Over time, new growth can be observed. The red maple and red spruce has significantly increased from 2004 to 2022. See this in Figure 2 and 3. This new growth comes from the disturbance event Hurricane Juan and the restoration efforts taken afterwards. After Hurricane Juan, many down trees were removed for new growth, but not all, as down trees provide important ecological benefits. We predict that the dominant species will continue to grow as it reaches its climax before eventually reaching a plateau. This is because the dominant species have a high growth rate but can only grow until carrying capacity is reached. This explains the plateau. They will have steady growth due to competition as well.
The community metric of species richness of trees has increased from 2004 to 2022 since Hurricane Juan struck. This means there are more variety of species of trees found in Point Pleasant Park. There is more of a variety because given that there has been a hurricane, the climax community was eliminated and succession began again, meaning there is more room for more than just one dominant species of trees to exist. We predict that the species richness will go down as succession moves closer to the climax community. Research has shown that canopy cover can affect succession rate because certain species of trees can thrive with more shade. Pioneer species such as the red maple have had a higher successional rate as there are factors such as canopy cover that lead to more populations of red maples persisting. This would apply to Point Pleasant Park because as a result of the hurricane, there would be less canopy cover because of all the felled trees, allowing other species of trees to grow. But as they do, their canopy cover increases and the red maple will be the species that thrives within those conditions. As a result, the red maple will be dominant as the climax community is approached, leaving less variety of species and effectively lowering species richness. For a statistical analysis, we used a regression test, which showed an R-squared value of 0.655, which means that the relationship between species richness and time is significant.
Based upon the results of our data, it seems that the Acadian forest in Point Pleasant Park is regrowing and displaying signs of succession. In every graph, figures 1 through 4, succession can be observed. The density, dominant species, red spruce, and red maple, and the species richness have all increased since Hurricane Juan from 2004 to 2022. These results suggest that the growth will continue most likely until carrying capacity is reached. However, Point Pleasant Park is an urban park and this can present challenges for natural growth. Due to the need for walkways, many trees have been cleared and to make paths, disrupting the growth. Additionally, after Hurricane Juan, cleanup efforts removed many of the down debris. This can have some benefits, but removal of too many can have negative impacts on the forest, such as less homes for animals and less nutrients for new trees. One way we can ensure the healthy regrowth of the forest is to use traditional indigenous ideas. One idea is two-eyed seeing. This is an idea that to grow together we must take views from both Western and indigenous cultures. This way we can learn together and help the world around us as one. This is why we believe we should take indigenous traditional ideas on the environment into consideration for the best of the forest.
We would like to thank the Dalhousie Biology Department for providing the resources and support to complete this experiment. In addition, we would like to thank Allison Schmidt for providing the data and graphs needed to complete this laboratory.
Our references include 2007 Post-Hurricane Vegetation Recovery in Urban Forest, Chapter 2 of the Biodiversity Guidebook, Guiding Principles, Two-Eyed Seeing, 2004 Forest Ecosystems at Point Pleasant Park, 2016 Post-Hurricane Succession of Trees and Ground Flora in Point Pleasant Park, and What is Ecological Succession?